Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and US.
The problem is the following. So there is an n is a positive number, positive integer, such that this given expression is an integer. This information is given. And the options are you have to verify the truth value, whether the true or false. Their statements are given, n has to be even, 3 doesn't divide n, and 7 divides n, and 5 doesn't divide n. Before we move on to solving the problem, first step is to understand that uh, whether we are suitable enough to solve the problem, whether we have the knowledge. So first step is to understand what are the information given and whether we really understand the information content in the problem. So let's see. So the information given is n is a positive number. So n is greater than or equal to 0. There's an expression that is half plus 1/3 plus 1/7 plus 1 by 9, sorry, 1 by n. And it's said it's an integer, so it's is an integer, and it's asked about the following statements. Let's say I write like this, that if a divides the number n, I denote it like this. If a doesn't divide n, I denote it like this. So this is a notation so that we can easily write the options. A doesn't divide n. So the first option says that 2 has to be even, that means 2 divides n. The second option is 3 doesn't divide n. So 3 doesn't divide n. The third option is 7 divides n. 7 divides n. And the fourth option is 5 doesn't divide n. Okay. So before we proceed to think about the solution, the first step of any problem solving approach is to understand whether you know the given information or not, whether you understand each and every statement of the given information. Without, if you do not know, if you cannot confirm that, you are not suitable enough to approach the problem. So whenever you're solving a new problem, let's say I'm telling you this strategy, even if you're learning, so go to the problem statement, see if you can understand each and every statement and word out of it. If not, then you have to go back and revisit the basics. So I want confirmation from all the students out here whether you're understanding or not. So now let's see how we can approach the problem. Okay, so we have to understand, so we have to see each and every statement. So let's see, A, B, C, D, all are of the same genre of questions. Whether there is an integer, so A is given, whether an integer divides n or integer doesn't divide n, given the fact that is an integer. Now you have to understand that what is providing this, this pattern, that, I mean, in general 2, 3, 7, 5 has no relationship with n, right? N can be anything. But here the information is given that this expression is an integer. That means for all values of n, it will never be an integer. For certain values of n, it will be an integer, right? So that is the core of the problem. It's telling you that for all values of n, if you put n equal to 1, -1, you will see that it is not an integer. So for certain values of, so the good practice of problem solving, either you're doing a coding problem or doing a mathematics problem or doing anything, if you want to see whether you're progressing or not, first step is to write down your observations carefully. Okay. So for all values, this is very important when you're starting out. This will, we all do this. If we say we are finding the solutions of a quadratic equation, we all do these steps in our mind. We store it in our mind, but we are being able to store it just because we have done it so many times. We connect to that memory out there. But when we are starting out, we need to do this have a discipline of this, doing this step, so that it stays in your mind. Okay. So for all values of n, the expression, so we cannot write this expression so many times, right? So let's call this a good name. Understand it depending on n, so we will write it f of n, right? So f of n is, for all integer values of n, f of n is not an integer. So therefore the question is prompting you, rather is asking you, that for which values of n, fn is an integer. Okay. For which values of n, fn is an integer, or its converse. Fn is an integer, then can we know which are the values? So sometimes what we think, this problem is a much more general problem. Sometimes we need to understand that the given problem may be easier. So we will solve an easier problem. So that's the first step always. We will never solve a complicated problem. This is a much more complicated problem, this one. So how to solve an easier problem, how to make the problem given easier, how to make the complicated problem easier. This simple thing is to take specific cases, take specific examples or cases. Okay. So, what is a specific case? The good thing is that this will always not be told always in the examination. But in this case, the specific case is given, right? The specific case is in this for A, you just select A is equal to 2. So we will so the good part is that all the options are making the problem easier in some sense. Okay. So the specific cases are given that we will check for A is equal to check individually for A is equal to 2, 3, 5, and 7. First, we will see whether 2 divides n or not. Okay, and rather what has 2 to do with this n and stuff? What is 2 to do with this each of these integers? So naturally, the first step is when we are seeing whether what 2 has to do, we have to take examples. So we can take n equal to 2, 4, and see whether it's an integer or not, right? That's a basic step we can do at least. See, I am again telling you that this is not always you will do from the scratch every single time. This is some initially you will start doing this, and then it will become a habit inside you, and you will just jump steps. But I'm telling you the minute steps that we are actually fundamentally doing. Okay, so if two is a if we are checking whether two divides n or not, we can check n equal to 2. We can fit these numbers, but since as Naman has said, you already know this. I am expecting you to know this stuff. So we can just say that if n is an even number, then n can generally look like n equal to 2k, right? 2 times a certain integer. And we can see that what has this expression to do with an integer or not, like this being an integer or not. Okay. So how do you check it's an integer or not? We just rationalize it and make it into a fraction. So if you want to make it into a fraction, we take its LCM, but we can just do generally, like, right? So we just take the whole multiplication below. So we can do 2 into 3 into 7. So 6 times 7, 42. Okay, and then we can take it upward and above. So, or you can do it in a simple manner. You can probably see that what is this expression, and we can reduce the calculation out there. So if you want to see its expression out there, you can see it's 42 and 21, 14, 6. So you see 35, 41, great, good. So you see that this expression is 41 by 42 plus 1 by n. Interesting. And you want this to be an integer. That means this is some number, let's say C. But if you're trying to understand, if you're reaching this step, this step may be abstract for you, right? So you can start doing it out here and you will reach the same step again here. But let me start with this step, that this is an integer. So this is the first. So you have to write, when you're solving a problem, you have to write it in terms of algebraic expressions to remind you what are the steps you need to do. So this is an expression of this very fact. So instead of again revising it and going every time to this statement that fn is an integer, you can directly go to this statement and check it out. So this is an integer. So this is one of the most important aspect. And then you need to see what we get out of this equation. What information do we get out of this equation about n? So we get 41n plus 42 is equal to n. C is a constant, C is an integer. Now we have to understand what we get about n here and what has n to do with 2, 3, 5, and 7. So can n be 2 times something? So can n be 2kc? So we have here 41 into 2k. So we are assuming n equal to 2k. Okay. So we get this, and let's go to the next step. It seems like we can take a 2 common out here. So we cancel this out. Now we get to this step, and that means, understand this very carefully, that for any k, if n is a multiple of 2, n is even, for any k, this statement should hold. For any k, this statement should hold. Now let's see, like, what do we exactly mean by for any case this statement should hold, right? For n equal to k is equal to, if is it given that n is a positive integer? Yes, n is a positive integer, so k should be greater than equal to 1, right? So for any positive integer, this should hold. Does it hold for 1? And c is an unknown constant. So let's see. So to get information about k, we should take all the k's to one side and non-k's to the other side, right? to get the entire information about k. We have to cluster the k's together. So we get 41k minus kc, or kc minus 41k is equal to 21. And we get c minus 41 is equal to 21. Good. So this provides you the information about k that is needed. You see the point? This provides you enough information about the k. So what do we get here? This is the integer, and we get that should be k should be a factor of 21.
If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.